Today we will talk about alkaloids. Alkaloids are naturally occurring organic compounds that contain at least one nitrogen atom, typically in a heterocyclic ring and exhibit significant physiological activity on human or animals. They are primarily found in plants but can also be derived from fungi, animals, and macroorganisms. Alkaloids, known for their wide range of pharmacological effects, alkaloids have played significant roles in medicine, toxicology, and biochemistry. The term alkaloid was coined in 1819 by the pharmacist Mistner and meant simply alkali like molecule. The first modern definition by Winterstein and Tier describe these substances in a broad sense as a basic nitrogen containing a compounds of either plants or animal origin, but mostly the compound originated from plants. Recently, W. Platier suggested the following new definition. An alkaloid is a cyclic organic compound containing nitrogen in a negative oxidation state, which is of limited distribution among living organisms. Already, I have told you it is present in plants. Uh, Less amount are present in living organisms. If we talk about the characteristics of alkaloids, mostly alkaloids derived from plant sources, contain one or more nitrogen atom, often in a ring, and they exhibit basic alkaline properties because they have a nitrogen atom and nitrogen atom in a cyclic system having a lone pair of electron that act as a base lone pair of electron. And alkaloid typically bitter in taste, mostly are solid crystalline substances. Few are liquid. Examples of liquid is nicotine. Alkaloid show biological activity often toxic in large doses, usually and in iron, just like morphine or quinine and caffeine. These are the examples of alkaloids. If we talk about the classification of alkaloids can be classified on the basis of biosynthetic origin. If derived from the amino acid alkaloids such as triosine and tryptophan, similarly ornithines, lysine. Um, Taxonomic based classification of alkaloids. This is done according to the source of compound like ephedra, cinchona, ergot. Ergot actually treated migraine headaches without reference to the chemical types. Further pharmacological activities, alkaloids are classified. Analgesics examples are morphine, antimalarial quinine, stimulant caffeine, anticholinergic atropine, narcotic codeines, and antihypertensive example is aspirin. Next, classification of alkaloid on the basis of chemical. The chemical classification of alkaloid universally adopted and depends on the type of heterocyclic ring system that are present in alkaloids. There are different type of alkaloids present in plant bodies, and the core ring which have a nitrogen atom. So on that basis, alkaloids are classified. Here's 8 example of classifications of alkaloids: pyrrolidine alkaloids, piperidine alkaloids, pyridine, pyrrolidine alkaloids, pyridine, piperidine alkaloids, quinoline alkaloids, isoquinoline alkaloids, phenanthrene alkaloids, and indole alkaloids. Now we will discuss one by one and discuss just briefly. Pyrrolidine alkaloids, here you can see that here is a pyrrolidine structure, and here is a two alkaloids which are very famous, uh, hygrine and cascohygrine. Hygrine is isolated from the leaf of the Peruvian coca shrub. Cascohygrine is found in casco leaf. There's pyrrolidine alkaloids examples, because the pyrrolidine are present in both alkaloids, so they are called the pyrrolidine alkaloids. Next is the piperidine alkaloids. As you can see, the different structure in which the piperidine ring is present, so they are called piperidine alkaloids. One of the example is here is quinine, isopallitrine, isopallitirene. Another example, here you can see that the piperidine is the core six-membered saturated ring, and lobeline and piperine, that is present in the black pepper. Here is a detail of all of these. Quinine occurs in a oil of hemlock and is poison to human. So pallityrene is isolated from the bark of pomegranate tree. Lobeline, obtained from the seed of Indian tobacco, is used in medicine as a respiratory stimulant and as a tobacco substituent. Piperine is a constituent of pepper. It's a black pepper actually. It is present in a black pepper. Botanical name is Piper nigrum, and number of other piper species. It is also present, this piperine. It is responsible for the hot taste of pepper, also used in a flavoring agent, insecticide, analeptics, and bactericidal agent. Pyridine and pyridine pyrrolidine alkaloids. Here you can see that pyridine and pyrrolidine, here is a core, and from this core here is a two example of pyridine pyrrolidine alkaloids. One is the nicotine and second is the myosmine. These are the two examples of the pyridine pyrrolidine. Nicotine is isolated from the tobacco leaf. It is highly toxic, which is very small doses causes respiratory stimulation, and in a large doses causes respiratory failure and death. Myosmine also occur in tobacco, and aroma of tobacco smoke is due to it. Next example is pyridine, piperidine alkaloids. Here you can see that, and the two examples of this is anabasine and antabasine. It's unsaturation, one double bond is unsaturated, but here is a totally saturated piperidine ring are present. Quinoline alkaloids is a core of quinoline, and from that there is a two examples of quinoline alkaloids, quinines and prima quinines. Here's a two examples, and the core is quinines. Quinines occur in a bark of cinchona tree. It has been used for centuries for the treatment of malaria. Synthetic drugs such as prima quinine have largely replaced quinine as a antimalarial. Uh, Another alkaloids of this group is captothecin, which is found in Chinese tree. As you can see that this is known to possess anti-leukemic and anti-tumoral activity in animals. Next example is isoquinoline alkaloids. Here is a see here is a core of isoquinoline, and from there here is two examples of isoquinoline alkaloids, papaverine and leudanosine. These are the two examples of isoquinoline alkaloids. Papaverine is isolated from the unripe seed capsule of opium poppy. It finds use as medicine in the treatment of spasms of the stomach or intestines. Leudanosine, also constituents of opium poppy, Papaver somniferum, is used as convulsive agent. Next example is phenanthrene alkaloids. These alkaloids contain phenanthrene nucleus. Here you can see that phenanthrene is a core, and from that here's the two examples. First is a morphine, second is a codeine. These are the examples of phenanthrene alkaloids. It has been shown that these alkaloids are derived from biosynthetically benzyl isoquinoline intermediate. That is why they are sometimes also included in isoquinoline alkaloids. Morphine is isolated from opium. It is used in medicine as a hypnotic, sleep producing, and pain relieving. Unfortunately, prolonged intake of morphine leads to addiction, and hence its use is restricted. Codeine is also obtained from opium and relatively non-addictive analgesics, antitussive agent, and possesses anesthetic properties. And the last is the indole alkaloids. Here's a basic skeleton of indole, and the examples are lysergic acid and strychnine. These are the two examples of indole alkaloids. Uh, Lysergic acid isolated from the fungus, the name is Claviceps purpurea, is the best known alkaloid of this class. In small regulated amount, it is used in the treatment of migraine headaches, as also for the induction of uterine contraction in childbirth. The dimethylamide of lysergic acid, LSD, is the most potent psychotomimetic substance known. It has varied effect on human, producing color hallucinations and psychotic state like those of schizophrenia. Next is extraction and isolation. There are various methods for the extraction and isolation of alkaloids. There's a steam distillation only for volatile alkaloids, and second is solvent extraction. Solvent extraction method is a versatile method. From that method, we can easily extract and isolate alkaloids. For extraction, actually, firstly, pulverized plant material actually is dip in methanol and get a methanolic extract. After that, dissolve methanolic extract dissolved in a distilled water and partitioned. And further less polar and hexane fraction we will get, and the aqueous layer acidified to a pH 2 and get the chloroform extract, in which non-basic medium polar substances we will get. Further, aqueous layer basified to a pH 10 and get the chloroform and ethanol fractions. And from these water insoluble alkaloid we will easily take. Further, aqueous layer with water soluble alkaloids added ammonium renicate uh, and ppt of alkaloid renicate will be generated soluble in acetones through ion exchange chromatography. Water soluble alkaloids we will get, and the aqueous layer further neutralized to a pH 7 and get the butanolic fractions, and from that saponin in a large amount we will get. The difference here's a structure of ranic acid. Uh, as you can see, the differences in solubility between alkaloids and their salts provide methods for isolation of alkaloids from the plant and their separation from the non-alkaloid substances. For the general method of structure determination, alkaloids mostly have complex molecular structure and determination, the determination of which is both tedious and challenging. This need a careful and systematic approach, which may involve following determination of molecular formula, uh, deduction of groups, estimation of groups, degradation, physical method, and lastly, total synthesis. So further we will discuss one by one. Determination of molecular formula in general elemental composition is obtained from combustion analysis, and after determination of molecular weight, molecular formula is calculated. Next is a deduction of group. The presence of various functional group in the molecule is determined by applying specific tests. It can be summarized as nature of oxygen functions, nature of nitrogen functions, presence of unsaturation. Nature of oxygen functions. Oxygen is usually present in alcoholic, phenolic, carbonyl, and carboxylic, methoxy, methylene dioxy, or ester groups, hydroxyl group. The alkaloid is treated with acetic anhydride, acetic chloride. It is a benzoyl chloride or acetyl chloride to yield a respective ester to detect the presence of hydroxyl group. Note the NH2 group also react with these reagents to yield the respective amides. The hydroxyl group may be alcoholic or phenolic. It is phenolic if the alkaloid give a coloration with ferric chloride. If the alcohol present in the form of phenolics, then give the coloration with FeCl3, and that is also soluble in a sodium hydroxide and is reprecipitated by CO2. If the above tests are negative, the hydroxyl group is alcoholic, otherwise a phenolic. If both are positive, both primary and secondary alcoholic group from esters, but primary on oxidation yields aldehyde, and secondary give ketone. Primary on oxidation yield aldehyde and secondary gives ketone. Uh, Further is a carboxyl group. The presence of carbonyl group is indicated by the formation of salts and esters and evolution of CO2 with sodium bicarbonate solution. Methoxy group. This group produces methyl iodide on heating with the hydroiodic acid. Here you can see the reaction. Further is a methylene dioxy group. Here is a group. If an alkaloid on heating with the hydrogen iodide or sulfuric acid yields formaldehyde, the presence of methylene dioxy group is indicated. Further is a carbonyl group. Here is a carbonyl group. The presence of carbonyl group is ascertained by usual reactions with hydroxylamine, semicarbazide, or 2,4-dinitrophenyl hydrazine. When the corresponding enzyme, semicarbazone or 2,4-dinitrophenyl hydrazine is formed, the carbonyl group may be aldehydic or ketonic, and the distinction can be made from tolerant reagent. Aldehyde gives silver miller, whereas ketone is unreactive. As you can see, the reaction of carbonyl group with the hydroxylamine and semicarbazide, and there is a 2,4 dinitrophenyl hydrazine. Formation of enzyme, semicarbazone, and phenyl hydrazones. Further is the esters group. The alkaloid containing the ester group gives an acid and an alcohol on hydrolysis. Nature of nitrogen functions. Nitrogen present in the form of amino groups or amide groups. The alkaloid containing amino group from salt with acids. The nature of amino group is decided on the basis of following reaction. Aliphatic amine react with nitrous acid to give a primary alcohol with the evolution of nitrogen gas. Aromatic amine groups form diazonic salt and dyes by coupling reaction. Secondary amino group react with nitrous acid to form nitrosamine. Tertiary amino group react with methyl iodide to form quaternary salt. Next is the amide group. Upon hydrolysis, the alkaloids containing an amide group yields the corresponding carboxylic acid, and NH3 ammonia evolve. Presence of unsaturation. The presence of unsaturation is indicated by treatment with bromine water or diluted KMNO4 solution. Reduction is also helpful. Next is estimation of groups. The estimation of various groups deducted as above is carried out as follows. Hydroxyl group through acetylation method. Here you can see that it's acetylation. After that, treating with the one normal sodium hydroxide, we will get alcohol and sodium salt of acetic acid. The excess of alkali is estimated by titration. Zerivatinov methods, the hydroxyl group or amino group are estimated by treatment with the methyl magnesium iodide. The volume of methane obtained is measured, which indicates the number of hydroxyl or amino group. Here's the reactions. 1 mole of alkaloid containing 1 hydroxyl group or 1 amino group. Carboxyl group. The number of carboxyl group may be determined volumetrically by titration against the standard barium hydroxide solution using phenolphthalein as an indicator. Methoxy group. The estimation of methoxy groups can be achieved using Zesel method, which is similar to the Herzinger method for nitrogen methyl group determination. A known weight of alkaloid is boiled with hydrogen iodide, which cleaves methoxy group with the formation of methyl iodide. This is then estimated by absorption of ethanolic silver nitrate, and the precipitated silver iodide is boiled with nitric acid, filtered, washed, dried, and weighed from from the weight of the precipitate formed. the number of methoxyl group can be easily calculated. Here's a reaction. You can see that methylene dioxy group, by treating with the acid, we will get aldehyde, and gravimetrically after the conversion to uh, um, dimidones derivatives, we will get easily estimated the methylene dioxy groups. There's a NH2, NH, and quaternary groups. How can we estimate it? These can be estimated by forming the hydrochloride and titrated it aqueous solution against normal solution of potassium hydroxide using phenolphthalein as an indicator. Amide, lactam, esters, lactones groups. These groups can be detected and estimated through acid or alkaline hydrolysis, epoxide ether linkage. Here's a structure of amide, ester, lactone, lactams. Here's you can see that how can we easily estimate it by treating with the base, and here's the HBr. We can easily estimate it through a treatment. Tertiary methyl group, the presence of tertiary methyl group is quantitatively estimated by Cohen-Roth oxidation to acetic acid, which is distilled off and titrated against standard base. Here is structures, reactions. Here's oxidation, and ultimately we will get acetic acid. Next is degradation. The alkaloids is decomposed by treating with suitable reagents to give simpler compound which can be identified easily. The following methods are used to find out structural fragment of alkaloid molecules. Here's Hoffman degradation, Amdes degradation, von Braun's method, hydrolysis, alkali fusion, and dehydrogenation. These methods are discussed one by one. Hoffman exhaustive methylation or degradation. Alkaloid is converted into a quaternary ammonium salt. Here you firstly uh, alkaloids, any alkaloids, converted firstly a quaternary ammonium salt by the treatment with the excess of alkyl halide, and the resulting salt is then converted into the most basic hydroxide by treating with the silver oxide and water. Subsequently, the quaternary hydroxide salt is heated at 200 degrees centigrade to give an olefin with the elimination of tertiary amine and water. In some cases, uh, however, the reaction can be carried out by refluxing an aqueous ethanolic solution of KOH containing methyl iodide or dimethyl sulfate salt of alkaloids. Here you can see the here's a quaternary salt, and ultimately we will get a olefin and the evolution of quaternary amines and water. The elimination generally produced by the E2 elimination, in which the beta hydrogen and quaternary nitrogen group are trans to each other. It's a basic thing. Always keep in your mind E2 elimination and beta hydrogen and quaternary nitrogen group both are trans to each other. The major alkene product is the least substituted and generally the least stable, and observation known as the Hoffman rule. If the nitrogen is present in the ring, two sequence of the degradation are required to eliminate nitrogen from the molecule. Here's you see here's a firstly form the quaternary ammonium salt after the heating. Firstly, it's a formation of olefin. After that, by the treating with the silver oxide, uh, there is a removal of the quaternary uh, amine and formation of olefins. So, thus, Hoffman degradation has been a useful tool in structure determination of alkaloids. The correct structure of lobular alkaloids, of which lobular 9 is typical, was first deduced from the Hoffman degradations. Here's a lobular and formation of quaternary ammonium salt, and after the heating it's a generation of olefin, and again the step when last step is repeated, a removal of quaternary amine, and ultimately olefins are generated. Hoffman degradation fails in following cases. If Hoffman degradation fails, then what will we do? Then the MD degradation follows, and ultimately we will get the result. The reaction fails in the case of derivative of 1, 2, 3, 4 tetra hydrodimethyl quinoleum hydroxide. Here's a quaternary salt which on pyrolysis is merely losses methanol without fission of ring. Here's a losses of methanol ring. There's a no ring fission. And however, MD degradation result in the cleavage of the ring. Here is the MD degradation of this quaternary ammonium salts that is proceed in the presence of sodium amalgam. Is a fission of the ring takes place. MD degradation, the alkaloid is converted to a quaternary ammonium salt by reflecting with the alkyl halide, and resulting salt is subjected to a reductive cleavage. By the treatment with sodium amalgam in alkanol or sodium in liquid ammonium by catalytic hydrogenation. Here you can see this one is a quaternary ammonium salt, MD degradation, and cleavage takes place. Again, there is a formation of quaternary ammonium salt. Then Hoffman degradation help out to fission reaction takes place, and ultimately the removal of quaternary ammonia. Next is von Braun's method. There are two types of von Braun degradation. In the first method, the tertiary amine, which contain at least one alkyl substituent, is treated with the bromocyanide. This result in cleavage of an alkyl nitrogen bond to give a alkyl bromide and substituted cyanamide. Here is the reaction of that. And with a symmetrically substituted amine, fission generally takes place to yield alkyl bromide derived from the smallest alkyl substituent. Here's a reaction of von Braun and the substitution of bromide and cyanide group. In the second method, secondary cyclic amine is treated with benzoyl chloride in the presence of sodium hydroxide to yield benzoyl derivative, which on treatment with tribromophosphorus bromine followed by distillation under reduced pressure to yield here's dihalo compound. Is dihalo compound after the distilled under reduced pressure. Elimination of benzoyl benzonitrile or piperidine yield 1,5-dibromopentane. Next is hydrolysis. Since many alkaloids contain ester amide linkages, hydrolytic fission in these cases leads to a smaller, more identifiable units. Piperine is an amide. It's a piperine, and this one is amide. After the treatment with the potassium hydroxide, we will get pipric acid and the piperidine. Alkali fission, which is very drastic method, which is often employed to break down the complex alkaloid molecule into a simpler fragment, which gives formation on the type of skeleton present in the alkaloid molecule. Quinine on Quinine on fusion with alkali gives 6-methoxyquinoline, 6-methoxyquinoline, and other products. Here's reactions. Papaverine on fusion with alkali yields two fragments fragments that account for all of the carbon atoms. Here's papaverine, alkali fusion, different compounds are formed with substitutions. Next is a dehydrogenation. In this method, alkaloid is heated with a catalyst such as sulfur, selenium, or palladium to yield a hydrogenated product which provides clue to the skeleton of the alkaloids. Pyrolysis or zinc dust distillation produces aromatic ring system. Pyrolysis of leucinol, leucinin gave 3,4-dihydroxy pyridine. It's a leucinol. After the pyrolysis, we will get a dihydroxy substituted pyridine molecule. Physical method. Recently, physical methods are used in conjunction with the chemical method to elucidate the structure of the alkaloids. UV spectra are used to indicate the nature of unsaturation. Infrared spectrum gives information about many functional groups. NMR spectroscopy is more versatile for detecting many functional groups, the nature of protons, carbon, heterocyclic ring. Mass spectral fragment gives the information about molecular weight and degradation of the skeleton. Single crystal X-ray analysis has offered means for determining or confirming stereochemistry as well as distinguishing between alternate structure that appears to fit well for a particular alkaloids. Further support of the stereochemistry can be obtained by using optical rotatory dispersion, ORD, and CD studies. Next, we will discuss about synthesis. The analytical procedures we have discussed above will project the tentative structure for the alkaloids under investigation because of the aforesaid physical method which are sure and accurate. The confirmation of the structure by synthesis of alkaloids is no longer that important. Nevertheless, synthesis will ever remain a fruitful method for confirming the proposed structure. It might produce a newer way of obtaining an alkaloid rather than depending only on natural sources. Sources of alkaloids. Plants are the major source of the alkaloid. Most alkaloids are found in flowering plants, angiosperms, especially in families such as Solanaceae, Papaveraceae, Rubiaceae, and Apocynaceae. These are the families having mostly alkaloids. Similarly, fungi ergot alkaloid from Calavicips purpurea actually get from the fungi. Animal sources and marine sources also get alkaloids. Biosynthesis of alkaloid. Most alkaloids are biosynthesized from amino acids. The biosynthesis involves decarboxylation, transamination, cyclization, methylation, hydroxylation steps. Examples: morphine is synthesized from tyrosine. Quinine is synthesized from tryptophan. Physiological and medicinal importance. Alkaloids are used for many medicinal importance as a pain relief, analgesics, morphine and codeine, stimulants, caffeine, nicotine, muscle relaxant, treatment of malaria, anti-cancer agents, heart drug, uh, psychoactive effect, LSD, just like masculine. These are the two example of psychoactive effects. Toxicity: some alkaloids can be highly toxic even in a small doses. Strychnine, a powerful convalescent poison. Aconitine, a cardiac and respiratory toxin. Nicotine, toxic in high doses, affects the central nervous system. Deduction and isolation: quantitative tests, Dragon-Troff test, Mayer test, and Wagner test. Dragon-Troff test is a very famous test, mostly used for the detection of alkaloids. Extraction technique: extraction with acidified water, use of organic solvents, chromatographic techniques for purifications. Examples of common alkaloids: morphine, papaver somniferum, actually get from papaver somniferum, and activities analgesics, quinine, caffeine, nicotine, atropine, reserpine. These are the common alkaloids used for the having different biological activities. Here you can see is anti-malaria, CNS, stimulant and addictive agents, cholinergic and antihypertensive. Overall, alkaloids are chemically and pharmacologically diverse group of natural product with significant biological and medicinal importance. Their study continues to be of high interest in natural product chemistry, drug discovery, and therapeutic applications.